Okay, let's see. All right, everybody. We are continuing our animation. Let's see. We were talking about motion and animation. So this is the other side of motion, motion through animation, and it is an entirely different way and useful way to move and animate and change and have parameters that change in real time. Not necessarily through coding. So it's another way to avoid writing code if you don't want to write code. So it can be very important. It can be your best friend if you like that as well. So let me make sure I've got all my streams and start recording and all that kind of great stuff. Yeah, so we're recording, we're this, we're that, we're over here. Whew, all over the place. This is going to be absolutely required for the next project. Yes. No, this is not, we're not learning about Disney animation. We're not learning about, just animating artwork or doing, video through animation. There is a specific type of animation. There's a specific type of controller. It's called an animator and an animation controller. It's part of Unity. Anytime you want to animate a parameter, most engines have something like this. So it's a matter of kind of automating real-time changes to parameters or to changes to images, or if you have a 3D object that 3D character that needs to walk, run, jump, throw, stab, and even if your characters need to do that as well, walk, throw, jump, stab, whatever, you have an RPG where your little character walks around on the screen, walks up, walks down, walks left, walks right. That's all done through an animator component. Now that animator component can also do things like animate your camera, move it around on the screen, animate the color of an object, animate the existence of things, animate motion. It can do all sorts of things. So this goes way beyond what you may be thinking of as animation, the simple case. So yes, it's very important. And one way or another, you will need to demonstrate the use of the animator or the animator controller, animations, and there's also another really, really important part of that called the state machine. Now, the state machine in Unity is usually thought of as part of the animator controller, and it's part of that hierarchy. In other engines, they have state machines that are considered to be part of like the AI engine, for decision making. But you can use actually the animator controller, or the Mecanim, used to be called the Mecanim controller, inside of Unity for all sorts of animated sorts of things, right? If it needs, something is doing something and it decides to do this or that or this based on kind of the progress of time, that's potentially a good use of the animator controller as well. It's not just a simple timeline. It's not just about graphics. It's way more than that. So that's important to know about. Now, let me make sure, let me open up a Unity project that will make sense to do this in. And yeah, it will all make perfect sense as we go through it. So even if I go through where's my intro project? I had to, just to make my life interesting, Unity decided to do a bunch of things where it suddenly got very, very confused about my team memberships, my Unity team support. And happens to the best of us, right? Not that I'm the best of us. And I had to rebuild a couple of different projects, but thankfully nothing was lost in the process. All right. So let me switch over here and talk about animation, a reference. All right. So this is where we're going to, it's not just for sprites. That's the key thing. It is not just for sprites. So Unity contains its own internal animation system, used to be called Mecanim. So if you hear something referred to as Mecanim, that is the internal Unity animation system. It consists of a bunch of different components that work interchangeably and a number of different assets that work with those components. Now, you may recall we had sound at some point, and we had sound, we had an audio source, and then we had an audio clip that would play that source. That's basically sort of a form of animation, even if you think about it, right? We have a sample, we have a movement of a speaker that changes over time, right? So we have this clip that automates or animates, ultimately the movement of a speaker over time. Crazy enough. Now, in the case of an animation controller, we're going to have a lot more control. We have things that are called animation clips that are going to tell us, okay, how do things change over the course of time? And then we're going to have two other parts, right? The clip itself is the thing that is going to contain information about how a specific game object should change its properties or its component properties over time. There's going to be the animator controller, which is a component that's going to keep track of when to play different clips, right? So should this clip happen now? Should this other clip happen now? Should there be some combination of clips? Should it be interpolating in between clips? It can even do kind of much more sophisticated things because it has this state machine, right? We'll look at the state machine in just a moment. All right, so there's an internal state machine using a flowchart-like language. It's almost a visual programming language a little bit. It's not quite like Bolt, but it is sort of visually programmed a little bit. Uses a sort of flowchart to keep track of different states that an object could be in. And what do I mean by states like that? Think of your character, your typical character in a platform game, Mario, Luigi, whoever, right? What are they doing? Well, they're standing idle. That's the state they may be in. Or they may be running, or they may be attacking, or they may be jumping, or they may be singing, dancing. There's going to be some state that they are in at a particular time, right? So we use a state machine to control that and to decide what potential animation clip or what process will be going on while they're in that state. What's going to be running while they're in that state, okay? So normally we think about, it governing the different types of states the object can be in, and usually it will be with regards to playing clips and triggering clips to change when those states change, right? So if you go from the idle state to the jumping state, or the idle state to the attacking state, or you make a smooth transition between a walking state or an idle state and walking state, and a walking state and a running state, right? You may have these sort of smooth transitions between states as well, things that aren't necessarily abrupt. Maybe they smoothly transition, all right? So that's the animator controller's job, is to know about all these potential states, to kind of referee between all the different clips, and even sometimes kind of manage the interpolation and blending between those. All right. Now, to put that together, there's also the animator component, right? There's an animator controller and an animator component, which maintains a reference to that object's animator controller, which is what in turn maintains a reference to the animation clips. Okay, so this is going to be a combination of these three things to do animations, to make them happen. Okay. Now, of course, in discussing, the uses for animations, normally you might think about the second one here first. Animating sprites, use of images or sprite sheets and a state machine to display different animations when a character performs a certain action. One of those, jumping, running, move left, walk left, jump up, down, die, idle, whatever they are, right? Those are the sorts of things. Now, let me pop out my screen here just in case, just to make sure if anyone has any questions and they're typing them out frantically and I haven't seen them yet. So let's do that. All right. So no questions over there just yet. Now I'll just put this over there. All right. So in addition to animating the display of something or the appearance of something using images or sprite sheets, right, you can also animate the properties of objects, right? The properties of objects. And that could be anything. It could be I was working with some folks in Game Dev 1 where they wanted to achieve this kind of radar effect. And I suggested, well, you can, I found a tutorial that used the animating of a clipping plane, which the camera kind of can decide, okay, how much of the field of view can be seen at any particular moment in time, and animating those clipping planes to give this kind of really wild visual effect where you can see further and then it kind of comes back again. So you can see like parts of the world, and it would animate that clipping plane to give you this kind of really cool visual effect. Or you could, anything as simple as animating the volume of something to give a smooth curve up and down, right? In any one of those particular states, all right? So I like to start off with animating properties, right? Because it's something you do directly in there. You don't need the art to do it. We can get some of the concepts down, and we don't necessarily have to create bitmap sprites to do all of this stuff, or images or videos or something like that, right? Even a video is just an animated bunch of frames over the course of time that you're playing. So let's jump into Unity and let's see, talk about this. All right, so 1 second. Uses for animating properties. Animation system provides it's an alternative to changing objects via code. It can be a lot simpler, faster to set up a quick animation right there in the editor. And some common use cases, adding effects to UI elements, popping things up, sliding them around, fading in and out, and so on, and simple behaviors that are easily assigned to an object. All right. This next slide, this is a cut and paste. This is okay, what we're going to do. Open the animation window if needed. All right, let's go do that. So here we are in Unity. And let's go to a scene. Let's see, what scene should we be in? Now, for now, I'm going to say, I've got some things already set up, but I'm going to create a new scene. So first thing, create scene. And we'll call this anim test. Okay. And we're going to open up anim test. And it has nothing really in the scene there, just empty. And what I want to do is I'm going to create an object that I want to somehow animate. Okay. Let's see. I'm going to grab what do I want to grab? I want to grab an image I'll grab from Mecanim here. Okay. So here there's a bunch of assets already set up. This is something that's been carved up into, this is a sprite sheet. So we have a file here, which is already carved up into things. And as we get into this sprite animation part, we'll get more into this. But the main thing is we're going to just drag an object in. Boom. There is okay. This is using, this is doing it a slightly more advanced way than I wanted to show. I'm gonna need you to, if you're just using the normal case, you should just drag this in and you should see the sprite happen right away, because you're just using the normal built-in pipeline, the built-in rendering pipeline. The thing I just had to do is, because this particular game, I forgot, this is using a different render pipeline. This is using the 2D lit pipeline, which you don't want to get into just yet. So you should be able to drag any image into your game and you'll just see that image there, right? It'll show up as a sprite. You see the sprite render. It will already have, a default render and material and things on it. You shouldn't need to worry about that. So just bring those in. If you have any issues, let me know. All right. So now I have this anvil here, and I want to do something. I want to animate the anvil. All right. Now we've been talking about motion. So let's animate the motion of the anvil. All right. So I'm going to say window, animation, open the animation window. Okay. And it opens it on the other screen. Let's pop up, let's go back, make sure I have, here we go. I said what I wanted to do was open the animation window if needed. Windows, animation, animation. So I opened up this animation window, and I'm going to put it at the bottom here. All right. So I put it at the bottom just so it's easily accessible. And so now it says, okay, select the object you want to animate. If that object has no animation clips, you click the Create button in the animation window. Otherwise, click the drop down of existing clips and create new clip. Okay. So you'll see right here, it says, to begin animating TX Village Props Anvil, create an animator and an animation clip. Because I already have that selected. If I didn't have that selected, if I had my hierarchy up here and I had nothing selected, well, it just knows that's the only thing in the scene, so it's going to give me that create. If I had other things in the scene, it might give me just an empty window here because it can't decide. But since I last selected that, that was what was there. So let's change that name, and we're going to just name that Anvil. We're going to do like a Wile E. Coyote Roadrunner game here. Now you'll notice to begin animating Anvil, create an animator and animation clip. It's still asking me. Great. Okay. Create. Now, it's going to make some assets for us at this point, right? So we're going to have to give it some place to put those assets because animations are going to have animated clips and so on that are separate from this game object and might even be used for other game objects if we wanted to. So let's create some state here. And we're going to create a new folder, and I'm going to call it animations. Right? So I've got this animations folder. Let's put that in there. And I'm going to name this particular animation, I'm going to call it Anvil Movement. Right? Anvil Movement. That's going to be my animation. All right. So what did that create for me? Now you'll notice in here, now if I go to animations, it's created two things. It has in fact created an Anvil controller and an Anvil animation. Right? So this is the actual Anvil movement is this animation. And it has created this controller called Anvil controller, which is this controller here, went ahead and created it for me, right? It put my animator component on there with my default. It created this Anvil controller for me. Right? So later on, I could create multiple one of these things and kind of load them into a particular animator controller at any particular time, or animator component. But we'll leave that addition for later. But so okay, we have this animator. You'll notice now down here, the animation window looks a lot more interesting because now it looks like what's called a timeline or a dope sheet or whatever, however you want to refer to it here. All right. So some interesting things about it. You'll see that it's asking me, do I want to add a property? And you'll also see what's really here, this Anvil movement. That is the name of the animation that I'm currently looking at. I may have multiple different clips within that animation or within this controlled by this controller, but for now, I just have simple Anvil movement, right? So that's the animation that I'm working with. And a few things you might want to do. You come up here and we can look for, let's see, did they change this on me here? I always like to show sample rate. Oh, I'm in Unity 2019. So hopefully, all right. Just because we're going to start all the way over. This is going to be a good review. All right. Yeah, we'll save all that. We're going to do it entirely fresh so that we can do it in Unity 2020. Because you know what? If we don't, everyone will say, wait, I didn't see where that button came from. Where was that thing? Where did they change that? Where did they move that to? So fall 2020, GSAS 2520. 2540, 2520? Yeah. Oh, the tragedy, the horrors. I should have remembered that right away. I was just on a tear, as they say. I was just going too fast for my own good, driving without the training wheels on. So we'll pause for a moment while Unity is over on the other screen for days on end here. Importing. I don't know why it takes so long sometimes. Hopefully Well, how's everybody's project going? Are we set there? Any project issues? Everybody's going well. Okay. All right. Everybody have them in on time. What's the date? When are we get 2 different classes with projects due now? I'm going to get all confused. That sounds about right. Yep, that sounds about right. Mid next week. Yeah. So my computer graphics class, their project is due today. So lucky for you, you're not them. All right, we're back. We have Snow Kid here. Wonderful. All right, good old Snow Kid. So let's decide that we have another scene, and we're going to go ahead. We're going to do what we did in Snow Kid with Snow Kid here. All right, we want in our assets we have. I didn't create a scene folder there. What happened there? Pictures, prefabs, scripts. Wow, what a mess here. That's not like me. Scripts has scenes in it. What's that about? That should be up here under assets. All right. I must have accidentally dragged that. That's the only possible reason that could have happened. So under here, I'm going to go ahead and what the heck? We're going to start working on our, we did apple tree. So let's work on shmup, the shoot 'em up. It's a blank scene. All right. So what we're going to do is we'll start with an asset that is going to be our wonderful Snow Kid. Or, well, yeah, why not? Okay, Snow Kid is still here. Snow Kid 0. There he is. Snow Kid. And we want Snow Kid to be moved without using any script now. We're going to use an animator to animate Snow Kid's motion. So let's go through again. We want to say window, animation, animation. All right. Now there it is at the bottom. It's still there. Okay, we have a, we also have a graph window if we were to do any bolt, but we're not going to do that just yet. So let's create an animation. We want to begin animating Snow Kid 0, and let's just name it Snow Kid, not Snow Kid 0, because that's better. All right. Create. Same process. All right. Under assets, we're going to create a folder called animations. And in animations, we're going to call this Snow Kid left, right. Okay. Let's be safe. So once again, we have Snow Kid left, right. This is the animation we are working on. We see now we have a Snow Kid animator inside the animator component, and it is currently, for some reason, we're editing the Snow Kid left, right animation. All right. So over here, we click, we say, make sure to show sample rate. All right. And you can say set sample rate. I like to not have this. 60 is awfully high. So I'm going to set this down. For sake of demonstration here, let's make sure, show sample rate. And you'll see it over here, samples 60. All right. That's the number of samples per second. As we get into images and image animation, that number is going to be even more important. But for now, let's say, okay, we want to animate at 12 frames per second. So this is 1 second now. You'll see 1.00 down here. And we have 12 samples. Each second is divided into 12 samples that we could potentially animate on. All right. If I hit play here, you'll see my window moves. I give 0 to 11 and life moves on, but nothing happens. There's no motion going on, nothing. So let's add a property. And you can see now any existing property here of the animator, of the kid that we're on here, the sprite renderer, the transform, I can't animate the animator because that would be turtles all the way down, as they say. But let's go ahead and animate the position. All right. So here is Snow Kid's position right now. And if I press play again to preview it, nothing happens. Right? I started the game playing. I didn't want to do that. And still nothing is going to happen while the game is playing. So let's stop the game from playing and go back here. You'll notice no animatable objects selected. All right, let's select Snow Kid. And there, we've got it back again. All right. So here you're seeing keyframes, right? These are keys that say, okay, this is what the position at that moment in time and what the value is. You see right now it's set to 0.351 for X and set to some random value for Y and 0 for Z up here. And as I move, they don't change. But say I wanted over the course of 1 second for our Snow Kid to move from here to some other location. So, you know, the Snow Kid would go from there to there, right? So let's play that animation. Nothing happened. He snapped back immediately to that location. Why? Well, because that's where the animation is telling it to go. So even once we have an animation for it, this has an absolute position for Snow Kid to be at, right? Move down there, play the animation, boom, right back to where it was. All right, so we're already moving Snow Kid. But let's move Snow Kid in a more exciting way. We'll bring it over to here. Now, it was nice to be able to drag it around. If I went down here, I'd have to do things like, well, let's see. I'm down here, and I want to move this maybe to there. Now you'll see, okay, Snow Kid's moving up and down because I changed the value over here. Now, if I moved over here and I set another value, you'll see that now I've got this sort of interim in between Y value, and I can go down and then up again. All right, so I've got some serious motion happening now, and I hit play, and it's jittery and jumpy. You'll notice it kind of bounces at that last moment. Why is that? Well, it's because the start frame and the end frame have different values, right? Which isn't necessarily great because it's not going to do this loop smoothly. So one thing I can do is say, well, this started off at this value. I'm going to make this one 0. And just for sake of argument, I'm going to make this 1.5. Okay. And then I can come over here and make that 0 and 1.5. So now it looks like Snow Kid is animating smoothly because it starts its cycle at the value, moves to whatever this in-between value is. And I can even maybe I'll move that. Watch this, right? Bam! He's like hammering down and then he goes back up again. Or you can do the opposite. Now he's kind of hiccuping, right? So you have two very different things. He hiccups if he moves up fast, or he hammers if he comes down fast. So hammering versus hiccuping. All right, so let's just have him oscillating in the middle there. All right, now if I play the game, immediately in the game now, Snow Kid is moving up and down. So I could have, if I went back in here into my game, click that object, click that animator, and let's see here. Come on, Snow Kid. There he is. So if I had wanted to, if I knew I had that left and right motion and I didn't have to worry about that random change, I could actually have created in here that random motion, right? I could have said, okay, halfway through, I want Snow Kid to start off at, let's see, we're going to make the Y position 0. And here, we'll just do both 0, 0. 0, well, I should hit return and make it 0. 0 there. Whoops, come on. Now, what happened there? Where's my, ooh, look at that. Got some extra stuff going on here. 0, 0. So say halfway in between, halfway in between, we wanted it to move to the X to be over here at 8. Go ahead and type 8. And lo and behold, now, if we press play in the game, Snow Kid is going to move over to there. And if we wanted to, this value over here, let's see, goes to 8. And then over here, we want it to move back to 0. Right? So if that loops, we now have motion without any scripting, right? We have just animated motion. Okay. So on this timeline, I'm keyframing, I'm setting at this particular time, this is the position I want him to be at. Now, if I wanted to kind of make life a little bit easier, there's also here this little red button, and I can put it into keyframe recording mode. And this is kind of fun because I can say, okay, move over to here and then move SnowKid up here. You'll notice it's automatically added a keyframe for me there. So now if I press play, it's added that keyframe because I was in recording mode, and anywhere I put things, it automatically added that. Okay. Well, yeah, it's animation, right? It's anything can be animated. Now, the thing about that's gonna be different than Maya, though, is that this is all designed to be done in real time and manipulated in real time, and we can change things about this as we move along, right? So the first thing we're doing is we are setting up an animation. Now, the other cool thing we can do, well, let's watch this, for example. I'm going to set it back into preview mode, or not preview mode, but my record mode. So here, maybe at this point in time, right halfway through, I can come up here and say, well, let's go to the sprite renderer and change the color of the sprite renderer to be red. You'll notice it's added here. You know, the sprite has turned red because now it's kind of adding that into the color. And it's added this new property in here, right? So it's gone from its default value here, which was no additional color, white, to go to red. And we could say, well, it should go back to white again at the end. So let's go ahead and you need to drop this down and say, well, no, at that point, be 0 again, or be 1, 1, 1. There we go. Be white there. So now, sorry. Okay, the dots are the value changing, right? So if this particular dot here, right, I've collapsed it down. If I collapse these all down, you'll just see a dot or there's a dot in each row. So look, along the line here, SnowKid's position is set here, 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 and here. Those are the keyframes. Okay. The rendering color is changed here, here, and here. So if I drop these down, I'm going to see more dots because the rendering color is actually a vector of these 3 values, red, green, and blue. And I can individually change those. And I can even individually move those, right? So I can say, okay, it's going to be more green there, So it's going to go between white to kind of a, what? Okay, somebody's on the road. Yes, it is. Yes, it is. So anyway, so that's the dots. The dots are actually a keyframe, right? A keyframe for a particular value, right? And anything can be keyframed anywhere. And I can add keyframes through this recording. So if I press record, now the keyframe is set here, and anything I change is going to be set to that value. Like I might say, okay, Y is changed. So flipped. And I go back down here. You'll see it's going to flip when it hits that point, and unflip when he goes back again. All right. Turn off recording. Now I can't always come back here and say, okay, delete that key at that position. And I can also even just say, well, remove that property if I decide, well, I don't want to add that. And maybe I don't want to actually change the color. I want to go ahead and just be messing with the position. Right. So it's a real easy way, again, if I have some kind of cyclical or, animated motion that isn't really driven by a script, it's not driven by an algorithm other than a simple kind of smooth timeline, time-based sort of animation like that, right? So that is sort of the basic idea when it comes to animating a property, right? Anything that's in here, you could even, as we added things in, like other components, let's see. There may be effects, there may be, mesh deformations. They could be, all sorts of things they could potentially add and then animate over the course of time. But motion, color, transparency, those are the very common ones. What I like to do, actually, this is an effect I like to use in a lot of my games for different things, is to have a fade-in animation, right? So I'm going to create another animation here. I'm going to create a new clip, and I'm going to call this one fade in. All right. And capital fade, capital in, save. All right. So nothing is being animated yet. What do I want to have animate? Well, first thing I want to do is I want to set the frame rate to be 12 is fine, right? And I want to set the length here. So sometimes this is like a painful process, but let's see, can I do this? We're going to say go to sample. This is weird. Like, so say I want something to last 5 seconds, and I know it's 12 samples per second. I'm going to say 60, right? And now, did it bring me there? It did not. Oh, I just forget how to do this. Why am I forgetting how to do this? Yeah, it's kind of weird. To set the end is definitely kind of odd. So now I've got the ability here. I'm going to set the number of, so I'm going to go to frame 24. So now I'm there, and I can put a key there. Say I'll put, again, this color, but I'm going to animate the alpha. So I'm going to make all the way there. Oh, I should say there. Alpha. There at 2 seconds in. And at the other end of the spectrum here, you'll see it's now color A. Zoom over here, I'm going to say it's 0 here. All right, so if I play this now, Snow Kid, kind of just fades in like that. Kind of a cool, I think it's a cool effect. I think it's kind of neat to use. Now, if I didn't want it to loop, this is one other kind of weird thing about Unity. Whoops, didn't mean to hit play there. If I didn't want it to loop, I have to go to do something crazy. Here was Snow Kid left and right. Here's fade in. You notice now what I'm doing now is I'm actually selecting the animations, right? So I'm back down to the assets folder in the animations subdirectory here, and I can see my different animations. And over here in the inspector, you can see certain things about the animations. And here is actually where I set whether or not they loop. And why this is the only place you can set that, I don't know. And this has been a complaint of mine for quite a while in Unity. 2017 all through 2020, they still haven't changed it yet. I know other people have that same problem, and I don't know why Unity hasn't changed that. But if I don't want it to loop, I need to disable it there. All right, so now if I play my game, if that animation, see, that wouldn't loop now, but you might be asking yourself, well, how do I get that animation to play? Because every time I hit play, I'm back to my crazy movement animation and not my fade in animation. All right, valid question. valid thing. And here's where we need to start to cross the line over to the animator controller, the animator component more. All right, so let's go back to SnowKid. Remember, he's got this SnowKid sprite and the SnowKid controller and the SnowKid animator. All right, so this is down here. I double-clicked on that. You could have also gone to Window, Animation, Animator, and we'll give you this Animator window. I'm overpronouncing that, I know. But now in here, this is that flow chart I mentioned before, this kind of state machine that the animator will use, right? And there's a few basic components in here that it just puts by default, and I'll zoom to kind of make sure we know about that other one here. All right. And you zoom with your mouse wheel. You can kind of middle mouse click and pan around and so on. So this is now the state machine. Right? We're at the base layer of the state machine. And you'll see we have something called an entry point. This is the green box says this is where we start off. When this animation starts, when this animator starts, it starts at this entry and is going to go to some other state. This is the entrance. And we've got an orange state here called SnowKid left and right. That was the first one we created. That was, the first one we created, so it was the default. If I right click on that, you can see it says make transition, copy, create new blend state, delete. It's already set as the layer default state, so I can't select it again. But there it is. If instead I wanted this to be the default, I could click on that, right click and say set as layer default. And you'll notice the little orange arrow is now pointing to that one. Right. So that's the basic way to say, well, now when I play, the default animation that gets played by that animator controller is that one. So when my game starts, I have animated the appearance of the SnowKid. And you'll see down here, it is playing that animation. Right. Now that I'm in here, I can say, okay, run through that again. And that's the basics of it here. All right, let's jump back to the presentation materials again. So we see where we left off of there. All right, so we selected the object we wanted to animate. It had no animation clip, so we said create. That gave us our animator component, and our animator controller. And we did a couple of things. We made some changes by clicking record and then moving things around. Right, to save changes at a certain position in time, you move that little white line across there, the timeline, and changes in preview made must be manually saved to take effect. Otherwise, I put them in. I didn't go in preview mode. I went to normal mode. And when you're done, you click play to see how it looks. That's what we did. So we had an animation. Right. We saw the animator state machine. Within the animator window, it allows us to control the different states for a given animator, and each state represented by an animation clip. We had the entry state, the state at which the object first begins on start. We have two additional states. Any state, which is going to stand in, this will become more clear later as well. It is a shortcut to make a single transition from other states, from any other state. So say, okay, go from any other state to a particular state. You may need to do that, right? Because a state machine is always going from one state to another state. Right? There's also the exit state, which is going to restart back to the entry state. If you exit, use the exit. All right. So we can add states. We can add transitions. Let's see what that means. All right. So in here now, maybe I want to add a state. If I right click and I say create state, create empty, this is just an empty state. It doesn't have anything to do on there. And so if I clicked on here, you'll see up here, there's none under motion. SnowKid left and right. This has the animation that is already in there. Fade in has the fade in. So I could actually just decide, all right, make that state also the fade in state. So this state is actually the same as this one. Now, I could say, well, okay, transition from there to there. This is still the default one, so that transition is never going to happen. So maybe I go ahead and I say, okay, set default state. And let's see. It created 2 transitions on there. That was a great thing for me to do. There we go. Delete one of them. Right. So we'll call this one extra fade. Why might I do that? Well, extra fade, I'm going to make slightly different. So here's extra fade, and I should say, instead of extra fade, we'll call it slow fade. We have slow fade and fade in. And a slow fade, I'm going to change the speed of slow fade to 0.25. And the normal speed, that's the normal one. Right? So I can change the speed of one versus the other. So now with that as the default state, I hit play, and it's going to slowly fade in. Right? So I've created a different fade. And then it ends, and it sits there, it does nothing. Okay. Now say I wanted to, I don't know, fade out. So let's do this. This is, I'm going to press my luck here. I'm going to say, okay, create state, empty. And we're going to call this one, well, not fade. Okay, that one, we're going to call this one fade out. And let's use the fade in animation for that, but play it backwards. -1 for its speed. I can play it backwards. All right. So now if I want to see what that looks like, I could preview that one. No, I don't have that. That's the animation here. No. All right. So let's say I wanted to go fade in, slow fade. That happened. And then immediately after that, I want it to fade back out again. So I'm going to make a transition from slow fade to fade out. And I hit play. And if we watch in the animator window here, slow fade happens. That's going to end when it gets fully in. And then it transitions to fade out. And that one runs. And then maybe we have another transition that goes to fade in again. And then maybe we have another transition to go to fade out again. So it's going to fade in, fade out, fade in, fade out, fade in, fade out. Keeping going over and over and over again. All right. Yes. That's right. What I did, I'll show you where I'm at here. So I go to SnowKid. I look at the animations for SnowKid. I'm going to look at the fade in animation. I'm going to drop this down. Well, it said, okay, the color is, I'm just animating the alpha channel of the color here, right? So when I went, well, normally I would say, let's see, add property. If I said sprite renderer color, I said plus, now it's going to have the whole color thing here. But the thing I was really interested in was color A, right? So now we can see all the color, and color A, the alpha, is going from 0, which is faded out, to 1, which is faded in, right? The alpha value of color is the transparency. I could have had them go from, white to fading in and made it purple. So he fades in, and fades a weird color to purple. Who would want to do that? Right. So the cool thing is that they're independent of one another. So I can edit the animation separately, and it'll just use and do the right thing in that animator, right? I could even say, well, if I had some other thing, I could somewhere decide, okay, let's bring this into another, add it to another state machine, add it to another animation. So you may have eventually you have 3D models of bipeds, of your actors, of your characters, and so on. And you might have a library of animations that you've made for bipedal humanoid characters, and you might drag those animations in even though you have a new character. So that's why everything is modular and componentized like that, because you can use, like, even the fade in animation here, I might use that in all sorts of things. And actually, one of my games, I do that, right? Enemies fade in, the player fades in. I use the fade out when building gets destroyed, and so on and so on. So I can use that animation over and over again to do different things, modify its speed, change its length, do all that kind of great stuff. All right. No problem. So this is just to demonstrate a little bit kind of the power of the animator and animations and so on. And this is just the tip of the iceberg right now, because what I just did even is I made these transitions were non-conditional. They happen no matter what, right? It just followed this chain, right? But maybe in a game, I have transitions that are triggered by other things, like the velocity of the player, right? The velocity of the player is increasing, the Y velocity is not zero. That means if it's greater than zero, that means the player is moving in this direction. So therefore, I should play a walk animation that moves up, perhaps. Or if the Y velocity has a negative value, then I should play the walk down animation, and left and right, and so on. So let's talk about that. Okay, so this is the animation of parameters, the animation of properties at the moment. Let's see. Where did we leave off? So the animation state machine, I did a little quick create a state, make a transition between states, and so on. You can have sub-state machines as well. Like even these things, I don't think anyone has really ever used a sub-state machine in here. But if I wanted to encapsulate these, if I wanted to like bind them all together to make another state that you could then go through, imagine right now I had this slow fade, fade out, fade in. Okay, that's going to be a thing, right? So those things, say I wanted to create a sub-state machine, and this, I'm going to, what I should have done is have them in here and created those states and so on. And then I could have been at the base layer, and instead of doing this, I would transition, make transition to that, right? I could have done that sort of thing. I don't have it all fleshed out, but you could do that if you wanted to make things a little bit more elaborate, but we won't worry about that. You can get really crazy and have states within states within states. So now we're just talking about, one level of state machine there. All right. Whew. That was a lot. That's a lot of stuff, right? We had these transitions, right? And the transition you saw just now, I just said, okay, move from here to there. There's a lot more control that you have over transitions. You can say how and when to switch between states, right? You can rename just as you can the states themselves. So you can name these state transitions, but only one state transition can happen at any particular moment, right? So you can only be going from one to another. It can't follow two paths, right? You can't like have one state that leads you to both. It's going to have to decide. It may decide sort of randomly or seemingly randomly, but you can never be splitting your state transitions into multiple states. And then we have some things that allow us to customize how things transition and potentially even how things blend. So imagine you were going from a walking state to a running state. You might want to have it gradually change as opposed to instantly changing from walking to running. Now, that's something that can really only be done in certain types of with certain types of animation. You can't use blending in all animations. You can't use it with sprite animations, for example, because it can't like interpolate in between a walking sprite and a running sprite. But if you had 3D models that had, individual locations of joints and things like that, much more elaborate, you could actually do blends between states. So that's the sorts of things you do. And then to say, okay, prevent the state from exiting or occurring until some condition. If none are set, the state will exit at the given time exit, which basically means, with no conditions, it just happens automatically. If I click on one of these, you'll see, right? Here's the stuff I was talking about. I click on that, I see, all right, here's my animation. This is my animation from slow fade to fade out. It does have an exit time, so it's basically after my slow fade entirely plays, that's when it's going to transition to fade out. It does have, in its settings, you'll see that there is an exit time. There's a fixed duration. There's a transition. These aren't going to matter too much at this point because it's just a simple, very, very simple transition. And it kind of, smoothly interpolates in between anyway. But you can tune these, right? And we'll see some special cases as we go on to stuff, right? So that's where that happens. But normally, you either can use the defaults or we can just turn it off. At least one condition or an exit time to be valid. Otherwise, it is ignored. That's fine. I think we can get away with that. Let's see if they can complain. Right. So basically, the oh no, I see what's happening. Nope. It's ignoring this transition. No, it doesn't like that. I should be careful about that. Now that I've turned it back on again, it will do the transition. Yes, it ignored that transition. So I got to pay attention to those warnings. So the warning again was transition needs at least one condition or an exit time. Okay. So I didn't have a condition on here. So normally I might have a condition saying, okay, go here if it's time to do that. And I'd set a condition. See this condition here. So I have no parameters yet in there. So it's easier to show the conditions in an actual sprite animation. So we're going to keep barreling through here. So let's see. We are at 3:30 and we have until, of course, 4:20. All right. So once again, if you are doing crazy project work and you need that and you want to just tune into this later, feel free to do that. But make sure you are going to watch this at some point because animations are required in future projects. All right. So let's do an animation. Let's make an animation do something really, really cool. So for this, let's see. Now in here in SnowKid, we did have lots of images, and we had the images specifically of this Mega Man character, I think, right? Now I'm not entirely certain how this is going to work because, well, I'm going to do this. Hopefully this will work reasonably well. I didn't create these, so I don't know what order they're in, but I'm going to drag this one into the scene and we'll just trust that to be. We're going to create this character over here now. Why don't we see a preview? Okay, here's a preview. And so the first three are kind of a thing. 3, 4, 5, 6, 7. Oh, that's a good one. 6, 7, 8. 6, 7, 8 are good. Okay, so we got some things I could make for some animations here. All right, good. All right. So we've got this character here. We're going to go ahead. We want to animate PNG fine. So we're going to call this. Am I getting that right? Is this Mega Man? I don't. Whatever. Here we go. And I'm going to add an animator. And And we had assets. We're going to keep them all in our animations folder here. And we're going to call this Mega Run. Okay, save. And let's see, we had 6, 7, 8. So we're going to grab 6, drag it in here. And 7, let's see, is that, so right now, that's what happens. That's our sprite over there. So there, and we're going to make this happen. This is going to be a, well, we'll animate it at 12 frames per second. We only have 1 frame so far, which is that one. 7. Now let's put this one at half a second later, and that one at there. And now if we, obviously not too good. So let's do this. We're going to move this one. And voila. We are now cycling between the 3. We can slow this down if we wanted, say 8 frames per second. Okay. So we're cycling here, 1, 2, 3, and then this is going back to here, right? So the moment we hit the end, we go back to the beginning, right? So I think this is going to go to next keyframe, go to the end. So next keyframe. Well, it's not showing us our loop. But effectively, that's what's going to happen. All right, so now in our game, we now have our character walking while this other character is fading. All right. Let's do a couple of other animations for the character though. So we'll select that character, and that is now our first run animation. So let's figure out some others. All right. We have 9, 10, 11, which is kind of a pushback. What's this one? 11, 12. I'm going to find a good one here. Let's see. I'm going to find an idle. Oops. That's sort of our idle there. One. We use these 2. Oh, maybe the first 3. We'll see how that goes. It's going to be a little bit weird because it slides at the same time, which isn't great. But let's say create new clip, and we'll call this Mega Idle. Save. And we'll put, again, zero, and we're doing it at what? We said 8 frames per second. The next one, and the next one, and let's see how that looks. There's that little bit of funky motion, which I'm not thrilled by, but it's just, we want animations that are a little bit better than that. Oh well, we'll let it slide for now. Pardon the pun. So if I hit play, we get the run, which really we don't want. We really would rather have the idle for that starter. So let's go ahead. We'll open up the animator window. You'll notice, because that was the last one selected, let's make Mega Idle our default state. All right. And what else can we do? So we have Mega Idle. We have Mega Run. Now, the thing about Mega Run here is that it is also running in a particular direction, right? So that wasn't ideal necessarily, right? We know it's running towards the right. So that's really kind of Mega Run right. So let's add a property here. Now, let's see. So I'm going to do is I'm going to create a new clip called, oh, I put that in the wrong place. We'll move that later. It's okay. No, I shouldn't have done that. We're going to call this one Mega Run Left. Okay. And we're going to use our same animations. We're going to set them 8, 3, 6, 7, 8. So drag that in. 6, 7, 8. But how am I going to make it run in the opposite direction? Right. Wait, did I get that right? Why does that look? It doesn't look right. Let's go back here. And I'm going to cheat. Watch this. Ready? 6, 7, 8. All right, there, I cheated. There, I got it right that time. Now, that is obviously running to, that's Mega Run. Oh, now Mega Run Left. Oh, that's the one that was messed up. So we're going to delete that one. Drag those in. All right. So I have Mega Run Left and Mega Run, which are exactly the same right now. So I'm going to go to Mega Run Left, and I'm going to animate one other parameter. I'm going to add a property. I'm going to go into the sprite render and say flip X, which is going to flip the direction of the sprite. So we'll add that. And we're going to turn that on. You notice it's now, oh, it's changed at the end. We want to turn, make it the same throughout. We can even delete that key if we wanted. So we have a keyframe for this one that has our sprite flipped, right? That's the cool thing about sprite renders. We can actually flip them. So this one now, the animation points in the opposite direction. We have that one, and we have this one. All right. And let's see. If we look in our animator now, we have Mega Run and we have Mega Run Left. Okay. And somehow now we need to decide what direction Mega Run and Mega Run Left, how does it decide which one to go towards, depending? Okay. So we can say that we need to have some control. Now over here, you'll notice that we have this layers and parameters, and starts off being empty here. And what we want to do is we're going to add a float, and we're going to call it X velocity. Right? Because ultimately it is our X velocity, or that's telling us whether we're going left and right. Right? If it's positive, we're going to the right. If it's negative, we're going to the left. If it's 0, we're idle. All right. And so we could say if we're at the mega idle state, we want to go to transition to Mega Run if what? We want to have this transition. We'll click on that. And we're going to put a condition on that. And the condition is going to be velocity is greater than 0 to go into that one. Well, we'll call it less than 0 to go to that one. Is that the left or right? No, left is that way. That's right. So it's greater than 0. All right. We'll create another transition that would say, okay, let's go to the left. Click on that one. And we're going to go there if velocity is greater than, no, is less than 0. So if we're standing idle and suddenly we start moving in one direction or the other, we're going to go back. So let's try that. Now, how do we get this to change, this x velocity? How do we hook this up now? How do we make this work in our game? So, bunch of work to do. Now we have to script this. We can't get around scripting everything for forever here. So we're going to do a real quick. What time is it? How much time do I got? 3:40, a little bit of time. We can do this. We can do this because this is an important thing. This is the basis of all your character animation from now on, and lots of behaviors important to have. So in our game here, in our Mega Man, pardon if I get it wrong. I know I'm forgetting what characters are from what. We're going to call this the Mega Move script. Create an add, new script. All right. So where's our Mega Move script? Come on, Mega Move. Here we go. Mega Move. And you're going to allow me to do, I'm going to cheat a little bit here. I'm going to go rather quick. One thing that I'm going to cheat is a little bit more of input system. Maybe I won't cheat. I'll do this legit. All right. So let's add a component, and we're going to add physics 2D, and we're going to add, well, a rigid body 2D. Right. And our rigid body 2D is going to not be dynamic. We'll make it, well, no, we'll make it dynamic. Okay. So it is dynamic. It's going to change over the course of time according to physics. So we're going to manipulate it by, no, these technically we should make it kinematic. We'll see. Maybe if it doesn't work, then it won't work. All right. So shortcut way to do this, easiest way to do this. So here's Mega Move. We're going to start off. We're going to say, get component, rigid body 2D, velocity equals new vector 2, and we're going to give it an x velocity, which is going to give it just a little bit, 0.50. So it's going to move 0.5 meters per second. Double note, we want it to be a float. We want that to be a float. All right. So we should really, just to be explicit, we should say game object dot. So this is going to say, for the game object we are on, get the rigid body component, set its velocity to 0.5. This is the brute force way. So if I pressed play now, we should see our character move. Okay, our character is moving towards the right. All right, so now we need to somehow still communicate this x velocity to that. All right. Whew. Brace yourselves. We'll do some typing. Game object. Get component. Animator. Now you'll see set bool there. You'll see set float there. See string name, float value. Set float, what was it called? X velocity. Now, this should actually be in quotes here. It's going to be the name of that object set float, and we're going to set it to let me type this in and I'll explain. Okay. So this line, we are telling the component, the animator component, that if it has this velocity, if it has this parameter, game object, get component, animator, set float, this is your parameter, that x velocity, set it to the x velocity of the rigid body component. Okay, so now we're starting it moving using this start up here, but we are setting it all the time. If it turned out to be 0, then this would be 0. If it's not moving, it's going to be 0. So let's even go one step further so we can kind of do this dynamically. Inside of update, I'm going to set this to be a number that I'm going to set from the UI. Right. So what I'll do is I will say public float speed equals 0. And I'm going to say that's my speed. So this line here kind of goes away. And this is going to be a real kind of hacky way to do this, because what I'm doing is I'm setting the speed according to the UI, the Unity editor. So let's see if I've managed to do that correctly. So I'm going to come over here. We have the sprite renderer, the animator, the mega move script that has a speed of 0 at the moment. So I hit play. Nothing happens. Now, if I've done it right, all right. Now, it didn't move back the other way, right? So let's see. Let's watch down here. So we start the game. The entry point goes into mega idle because that's where it goes when it starts out. We increase the speed, which is now given the x velocity has been passed in as, there it is, 0.1, 0.2, 0.3, right? So it's doing that thing. If we bring it back to 0, there's no way for it to leave this. It stopped moving, all right? It's hiding behind Snow Kid there. It did stop moving, but it had no way to get out of this state here. So we have to give it a way to get out of that state. So we could say, you know, now, okay, go from here, make another transition back to mega idle, which the condition for that should be, well, it can either be greater than or less than. It's kind of tricky here, right? So the x velocity, setting it equal to 0, it's kind of a pain. So how do we get back to 0? Well, normally what we would do is we'd have like some kind of really, really small band. So it'd be like close enough to 0 to get it to transition, as opposed to being exactly equal to 0. So this one here, I'm going to say that we certainly don't want to be in this state if our speed now to get to this state, it needed to be greater than 0. So let's assume that, let's put a little bit of a parameter on it. We're going to say, oh, if it's greater than not 0, but 0.0001. Right. And we'll transition. Oh, wait, here's, we're greater than 0.001. We're going to go to this state. And to get out of that state, we're going to say less than 0.001. And this one, we're going to say, okay, if it was less than, if we started off in mega idle state and we were less than 0.001, we're going to go to run left. And similarly, we're going to create a transition to go back to idle. If we are greater than negative 0.111. So we could actually say less than 0 to get there. And we could say greater than 0 to get there. All right, so the question is, if we're really, really, really small, we might do something odd. Let's see how that works. So save that. Let's play. And now you're standing still. Go that direction. Go that direction. Kind of transition through 0. If we get to 0, let's try to put 0. Go back to idle. Now you'll notice there is a weird thing that happens, that it doesn't transition immediately. That it has a little bit of a lag to it. Now, normally I'd want to use a keyboard or a input or a joystick or something like that to change the speed. But for now, I'm just kind of winging it. So that weird transition is because of this transition speed here. See this exit time? It's saying, okay, don't immediately go between one and the other, right? And now that I have some transition conditions, I can say, all right, let's get rid of that. And say transition immediately. I think that's going to work. So it feels a lot better now because it's going to immediately transition. Right. So the nice thing, one of the key things about it is once you set up this relationship here, right? Once you say, all right, this is how it's going to transition from state to state to state according to this X velocity. And in your script now, we've basically we've decoupled that animation from the actual movement, right? We could have the movement changed in any particular way we want. It could be according to X. It could be even according to physics, right? If you came along and you just bumped into the character and it started moving in some direction, you don't have to trigger, figure out what direction it's moving in, how the animation, how it changed and so on, because it's already just baked into this animator component that's running on it that will set the state of the animation according to this value that we're setting. So you just kind of like set it and forget it with regards to the animation being set that way. Any questions on that? It's a lot. It's a lot to take in. Let's take a look at the slides and see. So we have state transitions that we're doing according to here. We're using these conditions. And there's an explanation in here. So this is why this is a reference. Remember at the beginning I said, okay, animation's a reference, right? So remember, you're going to use your animation parameters that are defined in the animator window. You name those. You name your animation parameters. We named ours X velocity. And then we assign the value of that parameter in our script in order to trigger that switch between states when appropriate. We have different parameters. We have integers, floats, bools. We used float here, right? There's also a trigger, which is a Boolean parameter reset by the controller when the transition happens. So it happens and then it resets it automatically as opposed to bool just checking it, right? And the condition is we have the event parameter, the animation parameter to check. In our case, it was x velocity. The predicate, is it greater than, less than, right? And the parameter value to check the value against. Now, let's see. I'm trying to remember now. There was something. How did I manage? You can also do things like combines. Fact 0, it shouldn't go there. So I would say, oh, if it's so say I can add to say, oh, velocity is less than 0.01 and greater than negative 0.0001, right? To establish, okay, you can only go back to the idle state if it's really tight, within there. But we don't necessarily want to easier time going in there. Let's see. I'm forgetting something. There's another trick that I have to remember my tips and tricks for conditions here. So in some other games, let me show you some examples of how we've used that sort of thing. All right. So we'll save this. That's pretty good. Good start. So we have our mega character that can move left and right and automatically change the orientation, and even change the the flip. Usually I do the flip in scripts there. So I decided that time around, what the heck, we're doing it as part of the animation. That's cool. New technique. So I'm going to go back to intro project here. And yep, this is Unity 2019, but concepts are similar. And start talking about the shmup game, the shoot 'em up game. Sorry, the shoot 'em up, the AKA the bullet hell or enter the gungeon or, top down RPG sort of game, typically what we do, right? This sprite here is probably better suited towards a platformer or fighting style game as opposed to a top down shoot 'em up. So probably wouldn't be my first choice in a game for this type of project. So let's look at an example of the shoot 'em up game it's one particular sort of idea. See if this will behave, and then we'll call it a day. So just to get you thinking about your next project. All right. Just responding to somebody else in another project, another class. All these classes happening simultaneously. It's kind of crazy. What just happened? Where are we? We're still loading? All right, we're back. Remember where's the game here? Not adventure, not scarecrow. There we go. So this is my infamous Enter the Coingeon game, which is sort of inspired by any number of different things. And this is, I've added a bunch of techniques in here that will discuss how a lot of them work. but not necessarily all of them. Some of them are kind of 2D lighting, shading kind of stuff, which is an advanced topic we usually don't get into. But here, the idea of the game is we played a little character up here. And let's see if it still works. Let's hope the game works. It might take a second. All right. And we have a little character, and it actually has a flashlight. And hopefully, I don't know how well it comes through, hopefully. But you'll see that the character has motion. The enemies all have motion. So here's a little enemy that can't see us because we're behind it now. Now it can see us. So all of the animations that you see are driven by certain conditions happening in the animation controller, right? So the fact that I'm moving down, left, right, and up, even the kind of teleportation effect is an animation. Oh, that's one of our friends. We like them. I forget where let's see. We have to bring them somewhere. I forget now. Where do we bring our friends to? I forget. Oh, well, we'll just blow up our friends. Oh, I think they're just the wandering ones. They get in the way. They're just bother. So the squirrels are actually your friends. The squirrels will follow you if they notice you. These things are just a pain. And you don't kill anyone, you pay them off. They may be exploding, but you actually are throwing coins at them. So this is a totally non-violent game. Because that's my story and I'm sticking with it. So we attract these squirrels, and then once the squirrels are attracted to us, they'll follow us, as you'll see, and we lead them to the squirrel hole, and we get points for the number of squirrels we gather and the number of enemies, like this enemy here, that we quote unquote pay off. And you can get cool other weapons that shoot in all directions and kind of mega weapons and whatnot. And there's some teleport zones, and you can go to different places and various types of mayhem. And you can even go back to the other game. Oh, I don't have that enabled at the moment. So that's the usefulness of the animations, is that you can really kind of bake things into your characters. So like, for example, here, our hero, if I can find the hero, somewhere is hero. The hero has a script, but the hero also has an animator. And here's the hero's animation. And the logic is a little bit different, but it's, it's similar idea to say, okay, is it moving in an X direction? Is it moving Y up and no change in X? Is it moving Y down and no change in X? Or is it not moving in any direction, right? So this had a notion of, is X moving? And the flip, you'll notice here, it's just walk back, walk front, and then walk side. I didn't animate the sprite flip in this one. Instead, I did the flip as part of the script that was updating the position. So it's slightly different. And then here, what you'll notice that's different is that these are actually going from any state, right? So no matter what state I'm in, if my X direction changes, it means, okay, go into that one, right? So it kind of bypasses the need for transitioning from state to state. You can do clever things like that. So you can use, say, any state instead of, having, a state that went from here to there to the, this one going to anywhere. Otherwise, you can quickly wind up with these sort of, well, this one needs to go to that one, and this one needs to actually go to that one, and this one needs to actually go to that one, and this one needs to potentially go to that one, and this one, you get these kind of really crazy interconnected ones if you're not careful. That's why the any state exists. So you don't have to have every state pointing to every other state for certain types of things, right? So in here, for example, it will always go to idle if there's no motion, no matter where you were, no matter which one of these states you were in, it will always go back to idle if there's no motion. And similarly, it will always go to a sideways motion if there is sideways motion. Doesn't matter if you were idle or you're walking up or you're walking down. Right? So it will do things for you. All right. That is enough for today. I am wiped out. If there aren't any questions, then I'll leave it to you to have a great weekend, work on your projects, get to this. Some people have added, if you feel, up to it, if you're, excited about putting animations in. And some of the animation, might be simple. Maybe you have the tree that moves back and forth in your game already, and all you want to do is add a simple kind of idle animation for the tree kind of bouncing up and down, kind of being squishy or something like that. Or the apple rotates, or the baskets, sing a happy song or something like that. You can do just a simple animation that doesn't involve any transitions or anything like that, that just uses a clip or cycles through the number of frames, if you want to use that, just to create some liveliness to your game. That's certainly valid as well. All right. Okay, let's call it a day at that. Okay, you too. Have a great weekend. Sure. Go ahead and say watch. Yep. Okay. Okay. You're getting fancy in here. If you're, in certain cases like that, what might be happening, you've got that while loop there. So it might require you to actually check for the existence of that object. Like you might say, if other is null or something like that, before actually checking, is it first check if it's not null and then check if it's active in the hierarchy, something like that. It's certainly if the message you're getting is that, there's, not finding an instance or not finding a valid pointer to something like that. That's what I would check. So you're using triggers rather than colliders, or what? Okay. Yeah. So that's okay. So yeah, if you have something that isn't being immediately destroyed, or you don't want to impart, you want to be careful about imparting a force to, yeah, that'd be a good use of triggering. So I'll see how you wind up implementing it, what your design is. Okay, let me think about that one. So you start off, you're instantiating or starting the coroutine based on if that coroutine is null, start a coroutine because you entered that. Okay, and you're using the while there just to check. Is there a condition where, like, why should that be an if, or are you assuming under what conditions wouldn't that coroutine be able to be started? Right. Right, but why not use if there instead of while? Like if DPS count, yeah, because while they're just kind of, I would question why, is there some kind of weird condition where you're assuming that start coroutine isn't working, so it would kind of stay in there, and if so, yeah. I mean, another thing you can do is you could explicitly say to stop any current coroutines before starting a new coroutine. Be another way to do it. But that's okay. That's still. So when does that get set back to null again? Oh, okay. Okay. Um, so should you, if you're about to return there, shouldn't you set that to null? Yes. Right. So because if that ends, if your damage per second ends, you're going to want to, that coroutine is going to go out of existence, but your DPS count variable isn't going to have changed. So it's going to think that that DPS count reference is potentially still valid. I don't know if that's the problem you're having, but right. So where, okay. So damage per unit. So that's the actual coroutine, and you're passing it in. Oh, okay. Oh, all right. So basically somebody else comes along and destroys that unit while this is occurring. Okay. Okay. Right. Yeah. So you're gonna somehow have to, like, when you start the coroutine. I need a second for your screen to. It's just like blurry stuff right now. I can't see anything. Yeah, it's just no. Right now, I don't know. For some reason, you got some kind of. It's all just compression artifacts at the moment. Okay. Yeah. Okay. It's good now. It's good now. Okay. So what you need to do is, rather than check that I would say, rather than pass that in during the start of the coroutine, you need to set to somehow let it know, either through a variable, probably some type of field or variable for this class, to say this is the unit that we're currently damaging, right? It can't be damaging. So you need a reference to the unit rather than just passing it, because by passing it in there in the start coroutine, there is nothing. There's going to be no way for you to change that inside of that while loop there. Yeah, somehow you'd have to check. I mean, maybe you could just through checking. Well, since that is, I mean, you might be able to just check for null inside of that loop there, and to know that you need to break out of that loop, and don't check other.gameObject.active hierarchy or other.return damage without having checked that other is still valid. Well, even if other is not null, yeah. Well, no, it's the other, because the problem is even the other game up, like what's holding other at that point? Because if other is pointing to a component on another game object, is that right? Yeah, it's right. So that's what I'm saying, is somehow within this class you need to check the other to see if that's valid before looking at the game object on it, because it could be destroyed, right? So show me in this code where other gets set. Where that. So it's getting the unit component of the thing. Okay, I'm getting it now. Okay, it's taking me a minute here. So yeah, you're going to have to check to see, not just because if that other game object was destroyed, then you can't reference other, because that instance of that class is also destroyed. So you need to make sure that other is valid before checking other.gameObject is valid. Right. Is that component, the script is a component. So is that component still there? So what I would do in this case, if you know that that's going to be a unit, don't pass it. This might be a case to say, okay, what exactly should you pass start coroutine? I mean, you could pass it the game object and figure it from there, so that you could just say, well, then game objects, why bother passing it the component unit? Why not just give it the game object? Right. But yeah, that's the problem. Is you have to kind of distill it down so that you have some way of knowing that is still a valid game object and a component off of there. right? So you could say collision.gameObject. You wouldn't call collision get component, right? You can leave that get component piece out, right? And then that, I believe that reference will be updated, and you can probably check to see whether that is not null. Um, yeah, that's the, yeah. You may have to fix some subtlety to that, but that's gonna, because even other dot return damage, that line there, that's gonna have to be other dot get component unit. Yeah, so you'll um, I mean, or you could do something where you could say, well, okay, let the other know that this is happening, and if so, if it's destroyed, it can, kind of tell this one that it shouldn't be damaged anymore. Um, r- right, but there you could say, but now you could, since you have the game object, you can get the component, so you could say other dot get component unit dot or parens, return damage if you needed to. Now, in the other instance, you were checking. You were using a while for that other, or what? You had something else you said. If other is not null, return. Was that a while before, or what was that before? Okay. So if you're waiting for that to die, or you're saying, what's the condition for that coroutine to end again? Yeah. I just you think we. Okay. Because you might need to change that, or you might have to have another piece. Sort of have you have a multi-layer check in there, which might even be the sort of thing that's going to require you to have kind of a weird while in there, because you're going to have to do it while, or it might be like a do while kind of thing where you break out of it if other does not equal. If other equals null, then just break out of it altogether, and then you could say, while that is not null. So you might have to be a little bit more clever in terms of how you structure that loop, to accommodate for the fact that you have two conditions. You have to make sure that it exists. I guess you could just say while other does not equal null and other dot whatever, because at least then it'll check the first one and not bother doing the second one if the first one isn't true, in the case of an and. So it would prevent you from doing that. Yeah. Yeah. But yeah, I'm gonna have to run at this point though. But yeah, I think you'll figure that. It really is that it's going to come down to that though, just making sure that you have a valid reference in there, before you check the lower level pieces of it. You were just having a problem because you had a component, and you had to make sure that the game object of that component actually existed before you could check anything on the component. Yeah. All right. Okay. Uh-huh. Right. Mm-hmm. Okay. Yeah. Well, I guess if you could say that, yeah, you are managing. I mean, the things that we're introducing is, using instantiation, managing, creating multiple things using a for loop, um, instantiating things procedurally at certain locations, um, using an array to keep track of them. Um, I would, I mean, as long as you can sort of make a compelling case that you understand, how instantiation works, how arrays work, demonstrate those things. It looks like you're going in a more advanced direction anyway. So that's yeah. Yeah. I guess the key is right. Well, but you sort of have to think of it as, the reason we normally provide it to be that specific is to say, okay, definitely want you to use arrays, and that's the way you do it. Um, if you can make the case that you've demonstrated the techniques that you would have used for that, you know, that's the way to do it. Kind of makes it a little bit tricky. Um, it's just, we got to make sure you understand the basics of the language and the basics of instantiation and procedural generation of things and stuff like that. Okay. All right. No problem. I'll take care. Have a good weekend.